everyone, and welcome to Unit 2, Part 3. Today we are going to start on page 205, and we are going to talk all about kites and the triangle midsegment theorem. You'll definitely want a pencil and a calculator as well. So on page 205, we see here the quadrilateral here called GEOM. And quadrilateral means it's a four-sided figure, and we'll oftentimes call them quads. So if we look here at this four-sided figure, we have a couple pairs of opposite sides in here. So one pair of opposite sides is going to be side GE and side MO, because the term opposite means that they are across from each other. The other pair of opposite sides are going to be GM and EO, right? The other pair of sides. Consecutive sides then are going to be our sides that are next to each other. So for instance, MO and EO, or MO is also going to be consecutive with GM next to it on this side, so these two. But just like that, we also have another two pairs, because we have to look at the other pair of opposite sides, GE, which is also going to be next to or consecutive with EO, and GE also has GM on its other side. So this and this, those are consecutive because they're next to each other. Now, just like we have opposite sides, we also have opposite angles. So the opposite angles here are going to be angle E and angle M. And then we also have G and O are the other pair of opposite angles. So angle G and angle O. And just like we had consecutive sides, we also are going to have consecutive angles. So those are going to be the angles that are next to each other. So for instance, G and E, but also G and M. So angle G and angle E because they're next to each other. Angle G and angle M are consecutive. And then just like we were talking about before, officially O is consecutive with angle E as well. And O is consecutive with M since they're next to each other. All right, now officially then the last piece of this is looking at the diagonal. So we officially have two diagonals, okay? One of them is segment ME, and the other diagonal then is GO. And the diagonals are connecting those opposite vertex. So we have two of them in here, and again, they're the ones that are crisscrossing here across each other, connecting those opposite angles. Now, a kite is a quadrilateral with exactly two pairs of congruent consecutive sides, okay? So this is an example of a kite, and the reason that this would be considered a kite is because KI and KE, which are consecutive sides, are congruent, as well as IT and TE, which they're telling us below. So that's why it would fit the description of a kite. Now, another way you can kind of look at this too is officially if we divided this, if we connected one diagonal here, these two triangles are going to be congruent to each other by side, side, side. So triangle KIT is congruent to triangle KET by SSS. And we know from the last chapter that if these two triangles are congruent, then we know that all these other opposite angles are going to end up being congruent because of CPCTC and some things like that. So there are some features of a kite that we would want to know. And a couple of them relate back to what we were just talking about here. So that we have the two pairs of congruent consecutive sides. We talked about that. That's number one in part C. One diagonal is going to divide the kite into two congruent triangles. That's what we just talked about up above. And another important piece of this is that the diagonals are perpendicular to each other. Okay, so we see the right angle created here when we write this in. Okay, but there are three other properties down here that we need to write in, or I'm going to type in because my handwriting is kind of messy, especially in the small of a space on the Smart Notes. So one thing that we also know is that the other diagonal that's not cutting it into two congruent pieces, the other diagonal divides a kite into two isosceles. So, what do we mean by that exactly? Well, if we look back up here, and if I erase this, we can see it a little better. We have here the other diagonal is making this isosceles triangle number 1 and this isosceles triangle number 2, which we talked about because of those congruent consecutive sides. Right, the next thing then is for number 5, we also have one pair of opposite angles congruent. And again, that goes actually back to the idea of the CPCTC that we were kind of talking about a little bit ago, because officially when we divided this into two triangles, we said by CPCTC these are congruent. Well, that means this pair of opposite angles, angle I and angle E, are going to be congruent. So that's what number 5 is telling us. And then finally, for number 6, we have one diagonal bisects a pair of opposite. So when we have this, again, we know that these are officially going to be, because of that CPCTC, these two angles are congruent, and then these two angles are congruent. So this diagonal here bisected the opposite angles of angle K and angle T. Okay? So very important that you get this list written down to know all these properties that's kind of happening there. Okay. So our diagonals officially bisect just one. So they're perpendicular to each other. But the other thing here is that when our diagonals are drawn in, just this one was bisected. Just one is a perpendicular bisector. So don't be confused that they bisect each other. Just one of these diagonals will get bisected in these problems. Okay, so do they bisect each other? No. Just one diagonal is bisected. Okay, now moving on then to the triangle midsegment formula, which is always just kind of randomly thrown in here because everything else about this is all about quadrilaterals from here on out. But this is the one time we talk about a triangle midsegment theorem. And what this says is if we have two midpoints, M and N are midpoints, and if we have a segment connecting those two different midpoints, this side here is going to be half of this third remaining side. So in this particular problem, what's basically happening is that M is the midpoint of segment AB, and N is the midpoint of segment BC. So here and then here we were just talking about. Then we know that MN is parallel to AC, the third side, and it's going to be half the length of that third side, AC. Okay. So using that information, that we have a couple of practice problems here. Okay. Number 1 that I want to talk to you about is number 8. So here's number 8 is what we're going to focus on here. Is this the midsegment of a triangle? Okay. The answer here is no. And the reason is, in order for this to be the midsegment of a triangle, these two pieces would have to be congruent and these two pieces would have to be congruent. 5 and 6 are not congruent. Okay. Same thing over here. 5 and 6 are not congruent. So we would need them both to be, both over here, either to both be 5 or both be 6, and same thing over here in order for these to be considered midsegments. It really comes down to the fact that D and E are not midpoints, and they have to be considered midsegments, okay? The other problems I want to talk about are actually coming from the lesson practice portion of this, okay? So you see here in numbers 10, 11, and 12, a couple of problems. So reminder, if they're telling us that something is a midsegment, we know that this is a midpoint and this is a midpoint. So these two pieces are equal and these two pieces are equal, okay? The same side is getting cut in half. So what this means is that YF has to be the same as this piece was. These were both 4. And then XE and DX are the same size. Those are both 6. I know the picture doesn't necessarily look like that, but go by the given information here. Okay, so XY, we'll talk about in a second. So we said that DX is 6 and YF is 4. The midsegment itself then is parallel to the third side and half of that value. So half of 17 is 8.5. That's how long the midsegment XY would be. Okay. Now, when we are given these problems and their algebraic expressions, again, we know that this midsegment is half of the third side. So what we can do is if we double the midsegment, it would have to equal the third side, right? 8.5 doubled equaled the third side of this triangle. So what we can do to solve this is set this up so that we double the midsegment and set it equal to that third side. And this allows us to then solve for x. So don't forget to distribute. And then now that everything is condensed on the left-hand side, we could start moving it across. I'm going to subtract the 2x since that's smaller, which means I'll add the 5 so that we balance this out and we get 2x equals 12. So x is 6, which means when we plug it back in, WZ, the third side, 2 times 6 is 12, plus 7 is 19. And then when we plug x back in here, 2 times 6 is 12, minus 2.5 is 9.5 when we plug it back in for RQ, or QR. Okay. Last but not least, number 12 is looking for some different formulas dealing with our kite, so our properties of a kite. Well, reminder, your diagonals are perpendicular here. So BD is going to be perpendicular to segment AC, all right, based on those properties, which means triangle ABC in this picture is going to be congruent to triangle ADC. We talked about how that's split into 2 congruent triangles. Using CPCTC, angle ABC is congruent to angle ADC as well. Segment AB, it's a little easier for us to see, is this segment right here, which we know is going to be congruent to segment AD because the consecutive sides in this kite are going to be congruent. And then finally, BAC, this little angle right here, is bisected. Angle A is bisected to be the same as DAC, right? Those 2 little angles here are congruent, right? And those are some of the properties of our kite. All right, guys, we'll be working more with this in class. Thanks, everyone, for watching.